Hello children, how are you all? Hope you all are doing well. This is Krishnamurthy. You can call me as VKM, your chemistry faculty working at Basidia. In today's session, I'm going to start a fresh chapter, that is nitrogen containing compounds. Chapter name is nitrogen containing compounds. Under nitrogen containing compounds, we have amines and diazonium salts. Amines and diazonium salts. And nitrogen containing compounds from organic chemistry of class 12, we have two subtopics. Those are amines and diazonium salts. Amines we will discuss it separately. Diazonium salts we will discuss it separately. In today's session, we will be starting with the amines. What is the definition of amines can be given? These are the organic compounds having NH2 as functional group. NH2 as a functional group. If they have NH2 as functional group, such type of organic compounds are said to be amines. And these are derivatives of ammonia. These are derivatives of ammonia. Ammonia formula is NH3. Okay. In ammonia, if you observe, ammonia, I can write it as NH2H. If I remove hydrogen and place an alkyl group, then you will get RNH2. Remove another hydrogen, place another alkyl group. Alkyl group means R. It gives you R2NH. Remove another hydrogen, place another alkyl group, then you will get R3N. All these are the different types of amines. How amines can be derived in the sense, hydrogen atom of ammonia can be replaced by alkyl groups. If one hydrogen atom is replaced, then you will get RNH2, which is called primary amine. And if you replace two hydrogens in ammonia, you will get a secondary amine, that is called 2-degree amine. If you replace three hydrogens of ammonia, then you will get a 3-degree amine or a tertiary amine. Right? If all three hydrogens are replaced by three alkyl groups, that amine is called as tertiary amine. So, amines are derivatives of ammonia. So, if you observe the structure of that particular amine, I'll be taking a simple example, either RNH2 or R2NH or R3N. Anything can be taken. Nitrogen is forming 3 bonds here and it is having one lone pair. It is having one lone pair, so 3 sigma bonds and one lone pair. If 3 sigma bonds and one lone pair is there, then hybridization is sp3. Hybridization is sp3. Nitrogen hybridization is sp3. sp3 hybrid orbital of that particular nitrogen overlaps with the 1s orbital of the hydrogen. Right? 1s orbital of the hydrogen. And here if it is carbon, let us say, here it is carbon, then it is a primary amine. Then it is a primary amine. It depends on the type of amine, that hydrogen varies. And sp3 hybridization, so we can expect a shape of tetrahedral, right? We can expect a shape of tetrahedral, but there is a lone pair. Because of the lone pair of electrons, the shape is pyramidal. Due to the lone pair bond pair repulsion, to avoid repulsion, it acquires a shape of pyramidal. There are sp3 means 4 hybrid orbitals. In those 4 hybrid orbital, okay, 3 hybrid orbitals are forming 3 sigma bonds and 1 acquire lone pair. And the shape of that particular molecule is pyramidal, right? And the next, if you observe that shape, nitrogen is the central atom, which is having lone pair, and connected to 3 alkyl groups, let us say, 3 methyl groups. Then it is an example of a tertiary amine. It is lone pair, unshared electron pair, and the bond angle and the bond angle can be given as 108 degree, and the shape of the amine is pyramidal. Shape of amine is pyramidal. Very simple it is. Next, if you observe classification and nomenclature of amines. How we can classify the amines? Amines are classified into three types majorly. Amines are classified into three types. It actually depends on number of alkyl groups which are attached to nitrogen atom. How many alkyl groups are attached? Based on it we can classify. So first one we have primary amine. Primary amine. Formula RNH2. Nitrogen attaches to only one carbon. So if nitrogen attaches to only one carbon, then it is called as primary amine. This carbon is 1 degree carbon. Our nitrogen is attached to 1 degree carbon, hence it is an example of primary amine. Similarly, we have secondary amine. We have secondary amine. General formula R2NH. So nitrogen attaches to two carbons. Nitrogen attaches to two carbons. So here this carbon is primary, this carbon is primary, but our nitrogen is attached to two carbons, hence it is an example of secondary amine. Is it clear for you? Next we have third type, that is tertiary amine. Third type we have tertiary amine. Tertiary amine can be indicated as 3 degree. So general formula is R3N. So our nitrogen is attached to 3 carbons. If it is attached to 3 carbons, then that nitrogen is considered as tertiary, and that amine is tertiary amine. General formula R3N. It depends on how many number of carbons are attached to the nitrogen. Is it clear for you? Like that we have three types of amines. When we see the nomenclature, under common name we can give it as alkyl amine. We can give it as alkyl amine. For suppose if we have 1 carbon methylamine, 2 carbons ethylamine, 3 carbons propylamine, 4 carbons butylamine. So it depends on how many carbons which are attached to the NH2. So and then prefix can be given as alkyl. That is a common name can be given. In secondary or tertiary amines, if you observe that there are 2 or more than more groups will be present in that particular secondary and tertiary amines, right? In such cases, prefix di or tri must be added before the name of the alkyl group, like dialkylamine, trialkylamine. If it is methyl, dimethylamine, trimethylamine. If more than one alkyl group is present, then we have to add numerical prefix such as di or tri. In IUPAC nomenclature, in IUPAC system, alkane, we have to remove the E and add the suffix amine. So what is IUPAC name then? Alkanamine. IUPAC name is alkanamine. If that alkanamine is consisting of 1 carbon, methanamine, 2 carbons, ethanamine, 3 carbons, propanamine, 4 carbons, butanamine. Hope you understand that. So it is depends on the number of alkyl groups. And now for suppose if I consider RNH2, it is a primary amine, only one alkyl group, no problem, fine. But if it is a secondary amine, R prime, sometimes alkyl groups are different. Sometimes alkyl groups are different. In such cases, which alkyl group should be taken as a parent chain, which alkyl group should be taken as a substituent? That is very important, right? So if different alkyl groups are attached, to nitrogen, the longest chain becomes parent alkyl, and remaining is prefix in alphabetical order. which can be added as a parent chain here or which can act as a parent chain. The longest chain becomes parent alkyl. Or suppose methyl and ethyl is there. Which is longest chain? Ethyl is longest chain. So that is the parent chain and methyl can act as a substituent. These are the rules to be followed while you are naming amines. Let's try to understand with the help of examples. I am going to give some examples of amines for nomenclature. Basic example, CH3, CH2, NH2 is the basic example. How many carbons are there? 2 carbons are there. Common name. What is the common name? Ethyl amine. Alkyl group is ethyl. So, ethyl amine. What is the IUPAC name? Ethanamine. IUPAC name is ethanamine. Alkanamine, I told 2 carbons are there, hence ethanamine. Next example we have CH3, CH2, CH2, NH2. Common name. What is the common name? N-propyl amine. This is N-propyl amine. And here labeling, if you observe it, starts from here 1, 2, 3. At first carbon we have amine. So propanamine. That 2 propan, 1 amine. It is the IUPAC name of this compound. Propan, 1 amine. Because 3 carbons are there, propane. It's 3 carbon alkane is propane. Cut off E, place amine, propanamine. At which position amine is located? First position, hence propan, 1 amine. Understood? Next, CH3, CH, NH2, CH3. So whenever you see that CH3, CH3 group, this group is called isopropyl. So common name is isopropyl amine. Common name is isopropyl amine. How can you give the IUPAC name? Start from any side, amine is getting number 2 only. Hence it is 1, it is 2, it is 3. So total number of carbons are 3. So propan, at second position we have our amine. So propan 2 amine. It is the IUPAC name can be given. This is the way. First you have to select the parent chain, then give the number of carbon atoms, how many are there, depends on that root word you can give it, and add suffix. Suffix is anyway same, amine only. Next example, CH3, N, CH2, CH3. Children, if you observe it, it is one alkyl group, it is another alkyl group. 2 different alkyl groups are there. Then longest alkyl group or longest chain alkyl group is parent alkyl. So that is 2 carbons. That is the parent alkanamine. So 2 carbon, 1 is ethanamine. 2 carbon alkanamine, 1 is ethanamine. But at this N in which 1 hydrogen is replaced by methyl group. So I can write it as N-methyl ethanamine. N-methyl ethanamine. It is the IUPAC name. What is common name? This is methyl. This is ethyl. Right? So which one comes first? Ethyl comes first. Hence it is ethyl methyl amine. That is ethyl methyl amine. That is common name. N-methyl ethanamine. That is IUPAC name. Next example, CH3, N, CH3, CH3. All 3 hydrogens are replaced by 3 methyl groups. Obviously 3 methyl groups are there, in the sense 1 carbon is the parent chain. The very simple way to understand, CH3NH2 is called methylamine, right? I am giving common name. How many methyl groups are there? 3 methyl groups are there, hence it is called trimethylamine. It is called trimethylamine. IUPAC name. IUPAC name, if you observe it, it is a parent chain if you consider. Any methyl group can be considered as parent chain because only 1 carbon is there. So that I can write it as methanamine. How many methyl groups are there? 2. So N, N, dimethyl. N, N, dimethyl methanamine. If only one alkyl group is there in case of secondary amine, that is N-methyl. But here tertiary amine, it is N comma N. In some books, they will give N comma N prime. That is also fine. You can write N comma N or N comma N prime, dimethyl methanamine. Dimethyl methanamine. So that is a way to give the IUPAC name. Another compound I am giving C2H5, N, CH2, 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 CH3. Here C2H5 is attached. It is also another example of 3-degree amine. So if you observe it, it is a 2-carbon chain. It is a 2-carbon chain, but this is a 4-carbon chain. Longest chain can be considered as parent alkyl group. So start numbering from here. That is 1, 2, 3, 4. 4-carbon amine. What is the name? 4-carbon amine is butanamine. That too amine is present at the first position. So you can write it as butan 1 amine. But this nitrogen is attached to ethyl. This nitrogen is also attached to ethyl. Single nitrogen is attached to 2 ethyl groups. Hence I can write it as N comma N diethyl butan 1 amine. It is the IUPAC name. That is the IUPAC name. And common name, here it is ethyl. Here it is ethyl. But this whole group is called butyl. So what you can write it then? Diethyl butyl amine. Diethyl butyl amine. So it is common name. It is the common name. Hope you understand that. Next, one more example which is inclusive of double bond NH2, CH2, CH double bond CH2. But out of double bond and amine, which one gets the lowest number? Means obviously amine gets the lowest number. So 1, 2, 3. Total number of carbons are 3, right? So IUPAC name I am writing first. That is prop 2N. At second position we have double bond, that's why 2N. At first position we have amine functional group, hence prop 2N 1 amine. This is the IUPAC name. And a common name is allyl amine, because this group is called allyl. This group is called allyl and it is amine, hence it is said to be allyl amine. Hope you understand that. Next, NH2, CH2 6 times NH2. There are 2 amine groups. It is an example of a diamine. It is an example of a diamine. So common name, total 6 CH2 groups are there. That CH2 is called methylene. So I can write it as hexamethylene. 2 amine groups are there, hence diamine. Hexamethylene diamine. If you elaborate the structure, you will understand the IUPAC name easily. NH2 connected with CH2. Total how many CH2 groups we have? We have 6 CH2 groups, right? Any side you can start the numbering. 1, 2, 3, 4, 5, 6. At first position as well as at sixth position we have amine groups. Hence IUPAC name can be given as hexan. Strike of E 1,6 diamine. Hexan 1,6 diamine. It is the IUPAC name of that compound. Hope you have understood the naming of amines. Let's start giving the name of organic compound, that to aromatic organic amines. Aromatic compounds, if you see, basic aromatic compound is C6H5NH2. It is called as commonly aniline. IUPAC name is benzenamine. Continuation, that is benzenamine. Benzene amine. Benzene ring is attached to amine group, hence it is benzenamine, commonly called as aniline. For suppose if methyl group is there, NH2, here CH3. So methyl group is there in the sense that is called toluene. But along with NH2, if it is there, commonly which is called as orthotoluidine. Orthotoluidine. This can be taken as 1, it can be taken as 2. So 2-aminotoluene. 2-aminotoluene. So this is the common name. Orthotoluidine is common name. 2-aminotoluene is IUPAC name. Next, you can give another substituted aniline. So at fourth position we have bromine, that is called para position. So para-bromo-aniline, this is common name. In IUPAC name, how you will give it? 4-bromo-aniline or 4-bromo-benzenamine, that is also fine. You can take another secondary amine, another tertiary amine, of course. Nitrogen is connected to how many carbons? 3 carbons. Hence it is an example of a tertiary amine. This can be given as N-N dimethyl aniline. This is the common name. N-N dimethyl benzenamine. N-N dimethyl benzenamine, that is IUPAC name. Aniline is the common compound and well-known compound which we are going to discuss about in this chapter about aniline under aromatic amines. Aliphatic amines in the sense methylamine, ethylamine. Aromatic amines in the sense commonly aniline, whose formula is C6H5NH2. In benzene, one hydrogen is replaced by amine functional group. It gives you aniline or aromatic amine. Hope you understand that. Let's try to solve this question. Classify the following amines as primary, secondary or tertiary. See, our nitrogen here connected to only one carbon. Only one carbon means this amine is a primary amine. It all depends on nitrogen is connected to how many carbons. Is it clear? It's not depends on. It is not depending on nitrogen connected to which type of carbon. Depends on nitrogen connected to how many carbons. Here nitrogen NCH3 twice, CH3 connected to benzene ring. Here one carbon. Total how many carbons are there? 3 carbons. Hence this amine is 3-degree amine or tertiary amine. See next one, C2H5 twice, CHNH2. Our nitrogen is connected to only one carbon. Hence this third one is called primary amine. Similarly, C2H5 twice NH, C2H5. Our nitrogen is connected to 2 carbons. Hence it is an example of secondary amine. This is the way to distinguish primary, secondary and tertiary. Right? Nitrogen is connected to how many carbons? That is the only way. Next, if you observe a question from NCERT, write the structure of different isomeric amines corresponding to the molecular formula C4H11N. A. Write IUPAC name of all the isomers. B. What type of isomerism is exhibited by different pairs of amines. First of all, we have a molecular formula C4H11N. We have to write down the structures of the different isomeric amines. Let's start with the first one. See, CH3, CH2, 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 NH2. Total 4 carbons, 3 plus 2, 5, 7, 9, 11, N. So this is butane 1 amine. It's a primary amine. If you observe that, write IUPAC names of all the isomers they gave. That's why I gave first isomer of molecular formula C4H11N, whose IUPAC name is butane 1 amine. Next, I am writing structures along with IUPAC names. CH3, CH, then CH3, isobutyl it is, and it is NH2. It is said to be isobutyl amine commonly, and IUPAC name that is 2-methyl propan 1-amine. It is also primary amine. 1, 2, 3. At second position we have methyl and at first position we have amine. It's another isomer. Next isomer, if you see, CH3, CH2, CH, NH2, CH3. It's a small change we have done it. Earlier, okay, it has at second position. Now here at the first position, right? The small change, okay, I have done it. That is, if you observe it, starts from here 1, 2, 3, 4. So it is butan 2-amine. It is also 1 degree amine. Next we have CH3, C, CH3, CH3, NH2. It is also primary amine, but you can write it as, total number of carbons we have 1, 2, 3, parent chain. So we can write it as 2-methyl propan 2-amine. It is also primary amine. So all these are the primary amines so far, A, B, C, D. So first two also primary amines, next two also primary amines. Observe it. Next I am writing secondary amine C2H5 NHC2H5. Next I am writing C3H7 NHCH3. That is secondary amine. And what is the IUPAC name of this? N-ethyl ethanamine. N-ethyl ethanamine. What about this? N-methyl propanamine. N-methyl propanamine. It is a secondary amine. It is a secondary amine. A, B, C, D are secondary amines. E, F are A, B, C, D are primary amines. Sorry, E and F are secondary amines. Next, if you observe few more, next I am taking CH3, CH, CH3, NH, CH3. So it is also secondary amine. IUPAC name is N-methyl propan 2-amine. Right? Next we have CH3N, CH3, C2H5. It is a tertiary amine. Previous one is secondary amine. So it is N, N dimethyl ethanamine. N, N dimethyl ethanamine. So total how many isomers we have written? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 isomers possible for molecular formula C4H11N. We have written all the isomers along with their IUPAC names. Hope you understand that. But still, they gave a question, what type of isomers is exhibited by different pairs of amines? If you observe clearly, A, B, C, D are primary amines. But next if you observe that, okay, next what we have EF. That EF is secondary and G is also secondary, but H if you observe that is tertiary. So generally this primary and secondary are functional group isomers. Similarly, primary and tertiary are functional group isomers, right? So first of all, we will be writing chain isomers. Chain isomers, A and B are chain isomers. A, D are chain isomers. Next, B, C are chain isomers. C, D are chain isomers. There is a difference in the chain length, but both are having same molecular formula. Next, positional isomers. Positional isomers. A, C are positional isomers. B, D are positional isomers. F, G also positional isomers. Means position of that amine group, if it changes, those are said to be positional isomers. Next, functional group isomers. Children, functional group isomers in the sense which are having same molecular formula but different functional groups should be there. Primary amine is one functional group, secondary and tertiary amines are also different functional groups. All these are examples of functional isomers. I can write AE, similarly AF, similarly AG and AH. In the same way you can write it for all. BE, BF, BG and BH. Similarly with C, CE, CF, CG and with CH. As well as with D and E. Next part, D with D also, D, F and DG and DH. And we have with E and H are functional isomers, right? As well as F and H functional isomers. G and H are functional isomers. And if you observe that carefully, that is E and F, E and G, these two are examples of metamers. Those two are examples of metamers. EF, EG. I'm writing this E and F. See, on either side of functional group, if alkyl groups are different, such type of isomers are called metamers. On either side of NH, here ethyl and ethyl is there, but in F, methyl and propyl is there. Hence, EF is an example of a metamer. Similarly, EG also an example of a metamer. Right? Both those are examples of the metamers. So, in all of these questions, just we have gone through the isomerism once again. So far we have discussed about classification of amines, nomenclature of amines and examples based on the isomerism. Hope you have enjoyed the session, and these questions are from NCERT, and we will catch up in the next session with another topic. Until then, take care, bye and thank you.